taking derivatives using properties of logarithms. So let's take a look at an example. So we have an example here that says if f of x is equal to the natural log of x to the 4/3 times cosine of x all over 7x plus 6, we want to find the derivative. So we could find the derivative using our normal natural log derivative properties. We can do this, take the derivative of the outside, which is 1 over the inside. We can leave the inside alone, and then multiply it by the derivative of the inside, which is also known as the chain rule. However, the chain rule part of this, as you can see, would require us to use a quotient rule. So, can we take the derivative of this normally? Absolutely. Is it going to be more challenging because there's a quotient rule? Absolutely. So that's where the properties of logarithms come in, because they will help us simplify this expression down so we can avoid some of that more challenging math. So let's dive in. So I'm going to rewrite f of x. Going to rewrite f of x is equal to, and since we have division on the inside of the natural logarithm, that means we can pull it apart and rewrite this expression as the natural log of the numerator, so the natural log of x to the 4/3 times cosine of x, minus the natural log of the denominator, which is 7x plus 6. And then from here we can simplify this further, because we can see that inside of the x to the 4/3 times cosine of x there is this multiplication, and if we have multiplication on the inside, we can then pull apart the inside to be addition. So we can rewrite this as the natural log of x to the 4/3 power plus the natural log of cosine of x, and that's a horrible parenthesis, let's try it again, and then minus the natural log of 7x plus 6. And then the last rule that we can take advantage of here is the fact that in our first term we have a 4/3 power. And one of the amazing properties with logarithms is that we can now bring the power out to be our coefficient. So I can rewrite this as 4/3 times the natural log of x plus the natural log of cosine of x minus the natural log of 7x plus 6. And now that this is simplified, now we can take the derivative. And now we can take the derivative of each individual term. So, in the first term, 4/3 times natural log of x. Remember, the 4/3 is a coefficient, so we can just leave that alone. And then multiply by the derivative of the natural log of x, which is just 1 over x. Plus, then we have the natural log of cosine, so we take the derivative of the outside, which is going to be 1 over cosine, because we leave the inside alone. And now we're going to use the chain rule to multiply by the derivative of the inside. So the derivative of cosine is negative sine of x. And then minus, and then we can take the derivative of our last term. So the natural log of 7x plus 6 is going to be 1 over the inside, which is 1 over 7x plus 6, times the derivative of the inside, remember that chain rule, and the derivative of the inside is just going to be 7. Alright, so then the last thing we're going to do here is we're just going to start to simplify. So with our first term here, 4/3 times 1 over x, it's multiplication. So we're going to multiply tops with tops, bottoms with bottoms, giving us 4 over 3x. And then 1 over cosine times negative sine is going to be a negative sine of x all over cosine of x. And then for 1 over 7x plus 6 times 7, that's just going to give us 7 over 7x plus 6. And then finally, the last simplification we can do is we hopefully remember that sine over cosine is equal to tangent. So our final solution here is going to be 4 over 3x minus tangent of x minus 7 over 7x plus 6. And that is our solution. And while it might be more steps, it is more simpler steps than having to worry about the quotient rule and complex fractions and all that jazz. So, feel free to use either method you want. However, this one will require a little less thinking. Alright, so now let's take a look at a similar example, but there is a difference here. So, we want to find the derivative of f of x if f of x is equal to the natural log of 4x squared plus 4x plus 8 all over x to the 4th times tangent of x. And now the difference here is now we have our multiplication in the denominator. So, we're just going to have to be a little bit more careful here when we have multiple terms being multiplied together in the denominator. And what I mean, have to be more careful when we are pulling this natural log apart. So let's dive in to start pulling it apart. So we know that f of x is going to equal to the natural log of the numerator, which is 4x squared plus 4x plus 8, minus the natural log of the denominator, which is x to the fourth, times tangent of x, because remember there are two things being multiplied in the denominator here. Alright, so now if we look at our first term, the natural log of 4x squared plus 4x plus 8, there's no more simplification we can do there because it's addition inside of the natural log. So that will stay alone, so we'll natural log of 4x squared plus 4x plus 8 equals. Oh, sorry, not equals. Minus. And now we have the natural log with two terms being multiplied on the inside. And we know that when we have two terms being multiplied on the inside, we can pull it apart and change it to addition. So we'll have natural log of x to the fourth plus the natural log of tangent of x. However, here is where we need to be careful. We know that we have x to the fourth and tangent of x are both in the denominator. And since they're both in the denominator, that means they're both being divided by. And we know that when we divide inside a natural log, it should be subtraction. But we see that there's a plus sign here. It really should be a subtraction. So what we need to do is we need to make sure that we put our denominator in parentheses so that we can remember to distribute this negative into both of our terms, because both of those terms were originally in the denominator. So let's go ahead and let's distribute that negative, and we're going to get the natural log of 4x squared plus 4x plus 8 minus the natural log of x to the fourth minus the natural log of tangent of x. And now the last simplification we can do here is we do have an exponent here with x to the fourth that we can make a coefficient, giving us a simplified function of the natural log of 4x squared plus 4x plus 8 minus 4 natural log of x minus natural log of tangent of x. And now we just go to town to find the derivative of each of these three terms. And don't forget the chain rule. Alright, so for our first one, natural log of 4x squared plus 4x plus 8 is going to be 1 over the inside, so it's 1 over 4x squared plus 4x plus 8 times the derivative of the inside, which is going to be 8x plus 4, minus 4 times the derivative of natural log is 1 over x, and then minus 1 over the inside, which is tangent, times the derivative of the inside. So the derivative of the inside is secant squared of x. And now the last thing we need to do here is we need to simplify this down. So let's see, this is going to be 8x plus 4 all over 4x squared plus 4x plus 8, and then minus 4 over x minus secant squared of x all over tangent of x. But wait, there's more. We can simplify down this trig function. So we can simplify, or we can leave the first two terms the same and just simplify the trig function. So we're still going to have 8x plus 4 all over 4x squared plus 4x plus 8 minus 4 over x minus, we can rewrite secant squared as 1 over cosine squared of x, and we can write tangent as, if I could spell it correctly, sine of x all over cosine of x. Alright, so doing a little bit more simplification, 8x plus 4 all over 4x squared plus 4x plus 8 minus 4 over x, and then minus 1 over cosine squared times cosine of x all over sine of x. So I just rewrote the complex fraction. And from here we can see that one of the cosines in the denominator will cancel out with the cosine in the numerator, leaving us with the simplified form of 8x plus 4 all over 4x squared plus 4x plus 8 minus 4 over x minus 1 over sine of x times cosine of x. And you could have written cosine of x times sine of x, because remember, multiplication is commutative, so with multiplication, order doesn't matter. And there is our final solution. So tons of simplification there, a little bit of trig, but not so much calculus because we pulled it apart using our properties of natural logs. All right, and then finally we can do the same thing with our normal logarithmic function, so no longer a natural log, but a log base 5. But all of our properties of logarithms apply to both regular and natural, so we can pull this apart just like before. Or if you wanted to do the chain rule and the quotient rule and all that junk, you could do that as well. But we're going to pull it apart because it's simpler, just a little more time consuming. So if we're going to simplify this, and I have the wrong color, if we're going to simplify this, we'll get f of x is equal to log base 5 of the numerator, x to the 6th, cosine of x minus log base 5 of 5x squared plus 5. As you can see in the denominator here, we have two terms being added, not being multiplied, so we don't have to worry about that whole double negative in the denominator thing like we did in the previous example. But we do have multiplication inside of our first term, so we can know that we can split that log up a little bit more. So we have log base 5 of x to the 6th plus log base 5 of cosine of x minus log base 5 of 5x squared plus 5. And then this is simplified as much as it can be. So then we could take the derivative. So f prime of x is going to be, and let's just remember our derivative of logs with a specific base. So d over dx of log base b. And I'm going to say a variable u here because it's usually a function, so we can bring the chain rule into this. So the derivative of that is going to be 1 over u times natural log of b, and then with the chain rule it's going to be times u prime, or we could rewrite this as u prime over u natural log of our base. So in this case, the derivative of the inside goes on top, the regular inside goes by the bottom, and we multiply by the natural log of our base. So let's do that. So we have log base 5 of x to the 6th, and I lied. I guess we can simplify this a little bit further before we take the derivative. So let's go ahead and do that. And what I mean is we can take the 6 just like before and move it to the front. So this is going to be 6 log base 5 of x plus log base 5 of cosine of x minus log base 5 of 5x squared plus 5. Now it is simplified all the way, so now we can take the derivative. So let's see, we're going to get 6 times 1 over the inside, which is x, times the natural log of the base, which is 5, and then times the derivative of the inside, but the derivative of x is just 1, so we don't need to write that. Then we get plus, and then it's going to be 1 over the inside, which is cosine of x, and then that's going to be times the natural log of the inside, which is 5. And this whole thing is going to be multiplied by the derivative of the inside, so negative sine of x. And then minus 1 over the inside, which is 5x squared plus 5, times the natural log of the base, which is 5. And then we have to multiply that by the derivative of the inside, which is just going to be 10x. And now we're just going to simplify from here. So our first term is going to be 6 over x ln of 5 plus, and actually that should be a negative because of this negative sign. So let's make that change here. So minus sine of x all over cosine of x times the natural log of 5, and then minus 10x all over 5x squared plus 5 times natural log of 5. And that is it. You might be asking yourself, well, we do have this sine over cosine. Couldn't we simplify that a little bit more? absolutely you could, but I don't know if it's going to look any nicer. So here it is if you were to simplify that a little bit more. So it would be 6 over x times the natural log of 5 minus tangent of x times 1 over the natural log of 5. And then minus 10x over 5x squared plus 5 times the natural log of 5. So it doesn't necessarily look any neater. So I would say you can leave that as sine over cosine, but make sure you check that with Newton to see that it is simplified down the most.